Hello students, welcome you all. In my today's lecture, I will discuss the Pinacol-Pinacol rearrangement in 1,2 diol system. So this 1,2 diol system, it is also called as the Pinacol. So suppose if we have 1,2 diol system, so this in presence of acid catalyst. So this is called as the Pinacol. In presence of acid catalyst, this is converted into pinacolone. So this pinacolone is the ketone. So this would be converted into ketone. Okay, so this is known as the pinacolone. So this takes place with some rearrangement reaction. Now, so let us see the mechanism for this reaction. So suppose if we have this pinacol and this pinacol in presence of this H plus, that's an acid catalyst. So you can see this is a symmetrical diol. So this diol is the symmetrical diol, and in this symmetrical diol, first of all, what will happen? This OH group that would be protonated. This OH group being poor leaving group, after protonation that would be converted into water molecule, which is a good leaving group. So because this is a symmetrical diol, that's why any one of this OH group may get protonated, and after protonation, so you will see that would be converted into this OH2 positive charge would be here on the oxygen atom, and in next step this H2O molecule, this it will leave out. It will leave out and you will have a positive charge over here. So this is the tertiary carbocation which is formed over here. Now in next step, the migration of this methyl group takes place. So this is methyl group, this is methyl group. So any of this that will migrate and to neutralize this positive charge. So after migration, what you will see? You will see so you will have a positive charge over this carbon, and now in next step what will happen? This positive charge that would be neutralized by the lone pair of electron present over this oxygen. So driving force for this migration of methyl group, that is the neutralization that can take place by this lone pair of electron. So this is the migration of methyl group is taking place here. And finally, what you will get? And finally, this removal of this H plus from here, and we will get the pinacolone is formed. Okay, so this is about the symmetrical diol, this is the symmetrical diol which is present. Now suppose if we have unsymmetrical diol, and suppose the diol is in place of this methyl group. Suppose if we have one of the phenyl group is present over here. In this case, what will happen? In this case, now we have to see which OH group we should protonate, either this one or this one. Now if I protonate this one, then H2O molecule will get removed from here and positive charge will create over here. If I remove this H2O molecule from here, then positive charge will be created over here. Both are the tertiary carbocation, but the phenyl group which is present over here, that is stabilized much more in comparison to this methyl group. So that's why this OH group that would be protonated. So I should protonate this OH group, and now so this will get removed, and in next step what will you will this phenyl group is present over here, and you will have the positive charge over this carbon. Okay, now in next step the positive charge over this that should be neutralized, and that can be neutralized by the migration of one of the methyl group. So this one of the methyl group will migrate from here, and what we will get? We get the positive charge will now create over this carbon, and we have this phenyl group, and like this. Now this is being neutralized, and after the removal of this H plus, the product formed, that would be so this would be the product in this case. So this is the pinacolone which is formed. Now suppose if we have hydrogen in place of phenyl, if we have hydrogen, so what would be the product? Now if we have hydrogen here, then now in this case, which of this oxygen that would be protonated? No doubt this will get protonated because it is giving you the tertiary carbocation. So here I should protonate this OH group, and this will get removed, and finally we get the positive charge over here. Okay. Now in next step, what will happen? Now this positive charge that would be neutralized by the migration of this H. So here this migration of this will takes place, and finally, or we may write and after the removal of this H plus, we will have the this should be the product. So the migratory aptitude, we should follow the migratory aptitude order. If you will see the migratory aptitude, then the hydrogen migrates first, and then phenyl group, and then we have the tertiary carbon, and then secondary carbon, and then we have the primary carbon, like this. Okay, so in this way we should the migratory aptitude that we should be followed. Okay. Now suppose if you see next problem. Now this is also a diol system, and this in presence of H plus, then what should be the product? So either any one of that can be protonated, either this one or this one. So suppose I protonate this one, positive charge that will be created over here, and we have OH. Okay. Now in next step, this will get removed, and we have a tertiary carbocation which is formed over this carbon, and this is being now neutralized by the formation of the positive charge. That positive charge now that will be created over here. So how? So migration of either, so this bond will break, and this carbon, this will get migrated to this one here. So either this will get migrated to here, means this bond has broken down. So what you can write? You may write so this bond has broken down. We have OH group over here, and positive charge is created over here. Okay, so now we may write this bond, new bond is created over here. So finally, so this lone pair over oxygen, this will neutralize this positive charge, and we have the product. The product which is formed over here is and double bond, this carbon oxygen double bond is present over here. So this should be the product. Okay, in the same way, suppose if I have so this is another diol system, and now so what should be the product over here? How can we write the product? So any one of this oxygen may get protonated. So any one of that oxygen may get protonated, and we have suppose this is get protonated, and in next step the removal of this H2 molecule. So what will be formed? Positive charge on this carbon, now so this positive charge that would be neutralized, a new, so either the shift of this double bond will break, and the methyl shift that will take place over here. So when this methyl shift takes place, then how can we write? So we may write okay, so new bond, you may say this new bond is formed over here, and this is the new positive charge which is being generated over here. Now in next step you may join this bond. So this positive charge that is being neutralized, and the product formed, this is 1, 2, 3, 4, 5, 6 membered ring is formed over here. This is a 6 membered ring, and to this carbon atom, one of this 5 membered ring, that is. So this is the ketone which is formed like this. So this is the Pinacol-Pinacolone rearrangement. Now let's say the semi-Pinacol. So if you see here, then OH group is present on both the carbon. Now in semi-Pinacol rearrangement, so in semi-Pinacol-Pinacolone rearrangement, so in place of one OH, so one OH group is replaced by the either this NH2 group or Cl. So here one OH group is replaced by either NH2 group or this Cl group. Okay, so this is being replaced. Now suppose if we have in place of one OH group, if we have suppose this NH2 group. Now, so in this case, this reaction, if it occurs in presence of nitrous acid that is being formed by this NaNO2 sodium nitride in presence of this HCl. So this gives okay, so this nitrous acid, we know that it forms the diazo salt. So this one plus it will create here N2 plus. Now in next step, this N2 plus being a very good leaving group, so it will leave out. This will leave out, and we will have a positive charge over here. Now next step, the methyl shift, migration of methyl. we have a positive charge over here, and so finally we are having this ketone is formed. So like this. So this is called as the semi-Pinacol-Pinacolone rearrangement, where one of this OH group is being replaced by either NH2 and Cl. So if the Cl is present, then Cl can be leaved out in presence of some silver salt, because the silver salt that forms the this AgCl, and AgCl that can easily, or the silver can easily replace this chlorine to form the AgCl. So this is about the Pinacol rearrangement. Thank you.